In this video, we're going to have a quick revision in S block elements. I'll write every important points in the screen, note it down. Let's talk about S block elements. S block elements are classified into two. They are group 1. The part is group 2. Group 2. Okay, let's talk about group 1 elements. All the group 1 elements are metals except hydrogen. All group 1 elements are metals except hydrogen. All the group 1 elements are metals except hydrogen. And they usually have low density. Low density. Density equal mass over volume. Comparatively to the other metals, the S block elements have low density. They have smaller mass and larger volume. Therefore, overall density reduces. And the valence shell configuration, the large shell should be NS1. And the oxidation state is 1 plus 1. Most of the compounds are stable ionic compounds. Stable ionic solids. Most of the group 1 compounds are stable ionic solids. Most of group 1 compounds are stable ionic solids. We have seen some points. Let's start with 1, 2, 3, 4, and 5. There are main 5 important points. The group 1 elements are called as alkali metals. They are called as alkali metals. They are lustrous. And they are good thermal conductors. Good thermal and electrical conductors. They are good thermal and electrical conductors. 6, 7, 8. Okay, the group elements, they are all metals, and they have the density of group 2 is greater than density. They have greater density than density of group 1 elements. They have greater density than group 1 elements. And the valence shell is NS2, and the oxidation state is +2. And they are called as alkali earth metals. They are gray or silvery color. Gray or silvery in color. They are also good electrical and thermal conductors. Good thermal and electrical conductors. The reactivity. Let's compare the reactivity of them. reactivity. Group 1 is greater than reactivity of group 2. Reactivity of group 1 elements are greater than reactivity of group 2 elements. The reactivity is less because the reactivity of group 2 elements are less because they have completely filled shell. Their shell is completely filled. This is the shell 1 electron, and this is the shell. They are completely filled. The group 2 elements are more stable, therefore they are less reactive. Now let's talk about group trends. Group trends down the group. Down the group, we have 4 different things to discuss under this topic. First, let's talk about radius. Radius down the group. This is for both group 1 elements and group 2 elements. Radius. Then we're going to talk about reactivity, ionization energy, ionization energy, and softness of metal. Softness of metal. Okay. Group 1. And this is group 2. Radius, as we know, the group, when going down the group, the radius increases. That's simple, both are same. 1 and group 2. So the radius increases. Reactivity down the group increases. Ionization energy down the group decreases. And the softness of metal increases. Radius increases, reactivity increases, softness of metal increases down the group. Okay, the radius of group 1 elements is greater. This is greater. Comparison. Reactivity increases, reactivity of group 1 greater. And the ionization energy is greater for group 2 elements. And the softness, we can't compare softness. And the group 1 this is greater, and here this is greater. Now let's check the elements in the group 1 and group 2. Okay, what are the group 1 elements? What are the group 2 elements? Group 1 elements are, what are they? Lithium, sodium, potassium, rubidium, and cesium. Group 2 elements are beryllium, magnesium, calcium, strontium, and barium. Now let's talk about reactivity. Reactivity of group 1 elements and group 2 elements. reactivity with water H2O. I'll write the pen down, the period, groups, elements, lithium, sodium, potassium, medium, and cesium. This is group 1 elements. These are group 2 elements: beryllium, magnesium, calcium, strontium, and barium. We can separate these, divide this like this. Right, I'll do it again. We will use another color. Okay, done. These are the divisions, and they are, these two are special cases. They are special cases, and the beryllium will react only with steam. Reacts only with steam. And magnesium reacts only with hot water and steam. Reacts only with hot water and steam. And these, the elements in red box, react with hot water, steam, and cold water. Reacts with hot water, cold water means normal water, and steam. Overall reaction. Let's start the reaction for magnesium. Okay, magnesium plus H2O, hot water. This is solid, this is liquid. Magnesium hydroxide plus H2 gas, and magnesium solid plus H2O gas means steam. Magnesium oxide plus H2 gas. These are the reactions for magnesium. And now we'll check about these reactions with steam and water and the red box. Group 1 elements and calcium, strontium, and barium. They react the metal. I'll mark them as M. Metal plus H2O forms metal hydroxide plus H2O. These are the reaction. This is the summary for water reaction. And this is aqueous. And this hydroxide is also aqueous. For group 1 elements, reaction is common. For the group 2 elements, M plus H2O, they have the valence is 2, and therefore M2OH plus H2O. This is for group 1, this is for group 2. The physical states must be mentioned. Lithium, sodium, potassium, rubidium, and cesium. The lithium reacts gently with water. Gently. Sodium and potassium vigorously. and rubidium and cesium explosively. Reaction with oxygen. Oh, yeah. I'll write down the metals again. Lithium, sodium, potassium, rubidium, and cesium. Group 2 metals, beryllium, magnesium, calcium, strontium, and barium. I'll mark them. Now let's consider lithium. Lithium is a special case. Lithium. Lithium reacts with both. The air contains nitrogen and oxygen. Lithium reacts with both nitrogen. Lithium Lithium reacts with nitrogen and oxygen. Lithium reacts with nitrogen and form LiN Li3n. Lithium reacts with oxygen and form lithium Li2O. Li2 is a white powder. White powder. All three, all box, the elements in the green box, all elements produces metal oxides with reacting with the metal and oxygen, they produce metal oxides. I'll mark the metal as M plus O2 forms MO metal oxides. And the metals in the yellow border, they produces peroxides. M plus O2, they form M2O2, M2O2. And the elements in the red box, they form M plus O, they form superoxides. Superoxides. If we add to the water to these oxides, they will form metal hydroxides. We'll write that MO plus H2O. They form metal hydroxide plus they form metal hydroxides. If we add water to lithium nitrite, lithium nitrite is solid plus H2O. They will form lithium hydroxide plus NH3 gas, ammonia gas. This is a special reaction. And also the other metals also form hydroxides with oxygen. Sorry, hydroxide with water. And when we allow those hydroxide MOH to react with CO2, they form metal carbonates. Metal carbonates plus H2O. Metal carbonates in water. And if we allow those metal carbonates to react with Carbonate and water, they form metal bicarbonates. M2CO3 plus H2O plus CO2 has forms metal bicarbonates. Metal bicarbonates are solid. Two should balance the reaction. Now the reaction is balanced. And when we compare the solubility, soluble, these hydrogen carbonates means bicarbonates are less soluble than metal carbonates in water. I'll take okay, metal carbonates are less soluble. Sorry, metal carbonates are more soluble than metal bicarbonates in water. We didn't see the reactivity of lithium to lithium with water. See, okay. We'll continue. And also all the group 2 elements also react with group 2 elements. All group 2 elements. The green color box elements reacts with nitrogen. When burned with burning up. Example, we take as a metal plus N2 forms M3N2O1. The metal nitrates are solid gas. And now we are going to see about the reaction with acids. Now we are going to see about reaction with acids. Reactions with acids. All the metal has the same reaction as this. Alright here. Magnesium, sorry, M plus M3 nitrites plus H2O forms the metal hydroxide plus NH3 gas. This reaction is for lithium and group 2 elements. Now we'll talk about reaction with acid. All H block elements react with acid. All H block elements react with acid. We'll write an example. The example will take M solid plus diluted HCl or H2SO4 or HNO3. They form salts of the acid. Example, metal chloride. If it reacts with sulfate, metal sulfate. If it reacts with metal nitrite, they form metal nitrate. These reactions are highly exothermic and explosive. Highly exothermic and explosive. Now we are going to see reactions with hydrogen. Reaction with hydrogen gas. Reaction with hydrogen gas. The elements in next block produces ionic metal hydrides. H block elements produce ionic metal hydrides when reacted with water. They produce ionic metal hydrides when reacted with water. Important points. And let's write the reaction. Metal plus H2 gas, metal hydrogen, and the hydrogen in the metal hydride has an oxidation number. Oxidation number of metal hydrides. Okay, oxidation number of hydrogen in metal hydride. Hydrogen in metal hydride is -1. These metal hydrides react vigorously with water. That means these metal hydrides react vigorously with water. I'll write the reaction down here. And add solid plus H2O. They form metal hydroxide plus H2 gas. This reaction is for all the group S block elements. These reactions are for all the group the S block elements. These are the reactions with acids, reaction with acid, and reaction with oxygen, OR, or nitrogen. We can consider it as nitrogen also. And we saw the reactivity of water, reaction with water. These are the main reactions. Overall reactions summary. These are the summary. Thermal stability of S block element salts. S block element salts. The decomposition, we have 3 decomposition thermal stabilities. Nitrogen decomposition, actually means nitrate decomposition, carbonate decomposition, and bicarbonate decomposition. And let's see, the main point is thermal stability. Thermal stability increases down the group. Increases down the metals, lithium nitride, sodium nitrate, potassium nitrate, helium nitrate, cesium nitrate. The group 2 nitrates are beryllium nitrate, magnesium nitrate, calcium nitrate, sodium nitrate, and barium nitrate. We're going to separate these decomposition. We separate the lithium and group 2 as one group, and the other group 1 except lithium as another group. In all, most of the about 90% of the occasion, the lithium and group 2 elements react or act similarly. These are one group. Decomposition, okay. These metals MnO 3 2 MO plus MO2 plus O2 gas is also gas. Decomposition, and these elements, these MnO3 when heated they decompose into MnO2 plus O2 gas. The difference is here in group 2 and lithium nitrates decomposition. We see that we get nitrogen dioxide and oxygen. In group 1 nitrates we get MnO2 and O2 gas. Let's talk about decomposition of bicarbonates. Decomposition of carbonates. Here lithium carbonate, sodium carbonate, potassium carbonate, sodium carbonate, and cesium carbonate. Here are beryllium carbonate, magnesium carbonate, calcium carbonate, sodium carbonate, and barium carbonate. We separate these as group 1 elements and barium. The lithium carbonate and group 2 carbonates, they decompose. Now carbonate decompose into metal oxide plus CO2 gas. They decompose into metal oxide plus CO2 gas. And the group 2 elements, group 1 other elements except lithium, like metal carbonate, decomposition does not take place. There is no metal carbonate decomposition. and similar. This is similar to same, exactly similar to bicarbonate. Sorry, hydroxide. Let's mark it as hydroxide. Okay, and hydroxides. Okay, the OH minus ions. And we'll write the equation here. Magnesium metal hydroxide decomposition take place as they decompose into metal solid plus H2O gas, and here metal hydroxide heat, they does not decompose, they don't decompose, they do not decompose. These carbonates, group 2 carbonates are only stable in aqueous solution. They are only stable in aqueous solution. Stable in aqueous solution. And group 2 carbonates are not stable in room temperature. Not stable in room temperature. These are two important points. The NO2 is reddish brown color. Reddish brown. Now let's talk about the decomposition of bicarbonates. Okay, I'll write on the metals: lithium, beryllium. Sorry. Lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, cesium, barium. Yep. The variation, let me observe and divide these. This is group 1 and this is group 2. Okay. Let's see the bicarbonate decomposition. They decompose into metal bicarbonates, heat metal carbonate plus CO2 gas plus H2O gas, which is in aqueous form, and these metal bicarbonate heat metal carbonate 3 plus CO2 gas plus H2O gas. Both are same, but the metal carbonate produced is solid here. They form white precipitate. White precipitate. That's all for the decomposition. We learned about the nitrate decomposition, carbonate decomposition, hydroxide decomposition, and bicarbonate decomposition. Hydroxide and carbonate decomposition are similar, but the pattern for all the decomposition is lithium group 1, lithium and group 2 elements, and sodium group 1 elements except lithium. Okay, let's talk about the reason. Thermal stability reason, stability increases down the group. Thermal stability increases down the group due to cation radius of the cation increases and the anion size remains still. We'll write here thermal stability. Cation size increases down the group. Cation size increases down the group. And the polarizing power of the cation decreases down the group. Cation that increase polarizing power decreases due to decrease in charge density. This is the reason for thermal stability increase down the group. Cation size increases, polarized power decreases due to the charge density decreasing. Down the group, the polarizing power decreases. Highly polarized compound easily decomposes. Highly polarized compound easily decomposed. Highly polarized compounds are easily decomposable. Here, let's talk about solubility. Solubility of group 1 and group 2 salts. Point number 1, all group 1 salts are soluble in water except some of the lithium salts. They are lithium fluoride, lithium carbonate and lithium phosphate. All group 1 salts are soluble except lithium carbonate, lithium fluoride and lithium phosphate. And solubility can be explained using the Gibbs free energy. For all ionic compounds, let's take this. All ionic solids of group 1 are soluble in water, soluble in H2, soluble in water due to negative Gibbs free energy. Due to negative Gibbs free energy. All ionic solids of group 1 are soluble in water due to negative Gibbs free energy. Gibbs free energy in the solvation process. Now let's talk about group 2 elements. Group 2 solubility, all are soluble in salts of NO3 minus, NO2 minus, X minus means halide minus, and hydroxides, HCl bicarbonates, SO3 2 minus and S2 minus. These compounds are soluble. They are soluble. Soluble in H2O. Another point is salts of uni-negative anions are generally soluble. Salts of uni-negative ions are generally soluble. The compounds contain more than one uni-negative ions, therefore mostly something like phosphate. Phosphate, carbonate contain 2 minus, more than one uni-negative, not uni-negative, not uni-negative, and they are not soluble in H2O. They are not soluble in H2O. All carbonates are insoluble. Therefore, all carbonates are insoluble. All carbonates are insoluble. There is an exception, except beryllium carbonate. Beryllium carbonate. Bicarbonates are more stable than carbonates. Some of the important points are solubility of sulfate decreases down the group. Solubility of sulfate decreases down the group. And solubility of hydroxide and halides increases down the group. OH minus and X minus increases down the group. Solubility increases down the group. Increases. And we'll talk about basicity. Basicity down the group, basicity decreases. Basicity increases down the group. Increases across the period. Basicity decreases. Acidity, opposite of this, decreases across the period. Across the period, acidity increases. Down the period, acidity decreases. Acidity and basicity. Okay, let's notice basicity here. Let's change the color of this. Okay, now these are the basicity variation. Now let's see identification of S block elements. Identification of S block elements. S block elements. We use flame test for identification of S block elements. Flame test, and these are the elements and colors. Lithium, sodium, potassium, rubidium, cesium. This is group elements: beryllium, magnesium, calcium, strontium, and barium. Lithium is crimson red. Crimson red lithium. And rubidium, red violet. Red violet. And calcium, orange red. And strontium, crimson red. And potassium, iliac. Cesium, blue violet. Barium, yellowish green. Blue violet, yellowish green. Sodium, yellow. Magnesium, no color change. Mark the colors in the color, okay. Is orange, red. This is crimson red, and we'll check for the yellowish green. This is yellowish green. Let's check for blue violet. Okay, blue violet. This is red violet. Lithium, crimson red. Sodium, yellow. Potassium, iliac, rubidium, red violet. Cesium, blue violet. Beryllium and magnesium does not show. Strontium, calcium, orange red. Strontium, crimson red. Barium, yellowish green. Okay, that's all for whole summary and quick theory revision of S block elements. These are contain all the S block element nodes, main points, and theory, and the reactions. Watch this after 1 week and after 1 month, and you will remember this forever.